March 2017, paper 6. A student investigates the gases formed during the electrolysis of dilute sulfuric acid using the apparatus shown. Hydrogen and oxygen were produced. Complete the box to name the apparatus used. Of course, these are carbon electrodes. On the diagram, sketch how a sample of one of the gases could be collected. An inverted test tube above any of the electrodes is enough. No need for a measuring cylinder. You could use a gas jar, but no need of a measuring cylinder because he didn't say collect and measure. C. Give a test for oxygen. Glowing splintery lights. D. The gas collected at the positive side turned lime water milky. I. Based on this observation, what gas was present? Carbon dioxide, of course. Suggest how this gas was formed. Oxygen, which was produced at the anode, reacted with the carbon, which made the anode, to form carbon dioxide. So oxygen reacted with carbon. E. A solution of dilute sulfuric acid was electrolyzed for 1 hour. Suggest why the pH of the solution decreased during the electrolysis. Of course, when electrolyzing sulfuric acid, what is removed or discharged at both electrodes is hydrogen at the cathode and OH at the anode. This means that water is being removed or electrolyzed, and therefore the solution is getting more concentrated. Water is electrolyzed, so the solution becomes more concentrated, each for a mark. The second question, he's reacting a solution of sodium hydroxide labeled O and another one labeled P. Of course, they have different concentrations with hydrochloric acid. So this is basically a neutralization reaction. He used a measuring cylinder, which is an inaccuracy. He used a weird indicator, thiamophthalate. We're not used to it. This could cause slight changes in the endpoint. Okay. The readings are 29.64.1 and 25.5. The experiment 2 readings are 29.1, 24.0, and 5.1. Of course, all burette readings are to 1 decimal place. And then he's asking what type of chemical reaction occurs between hydrochloric acid and sodium hydroxide. It's neutralization. Exothermic is sometimes accepted, but neutralization is the best answer. Which solution of sodium hydroxide, O or P, is the more concentrated? In order to answer this question, you need to ask yourself, where did he put O and P, in the burette or in the conical flask? If you read, he put O and then P in a conical flask, okay? And he filled the burette with the same acid, same concentration and same everything, the hydrochloric acid, okay? And then O required 25.5 centimeter cube of this acid, and P required 5.1 centimeter cube of the same acid. This means that O was much more concentrated, therefore it required a larger volume of acid. So it's solution O because greater volume of acid was required. How many times is it more concentrated? 25.5 over 5.1. O needed 25.5, P needed 5.1, so it's 5 times as concentrated. The experiment 2 was repeated using 10 centimeter cubed of solution P. What will the volume of hydrochloric acid be? Okay, he used 20 centimeter cubed. He used 20 centimeter cubed of solution P, and this required 5.1 centimeter cubed. If he used 10, this will require half the amount, 2.5 to 2.6 centimeter cubed, of course. F, what would be the effect, if any, on the volume of dilute hydrochloric acid used in experiment 1? If the solution of sodium hydroxide was warmed, take care, this is a tricky question that he uses every year. When we're doing titration, we're not measuring the rate, we're measuring the volume of acid used. The volume is not affected by the temperature. No effect on volume because rate is not being measured, or because temperature affects only the rate. Okay, GI, what would be more accurate method of measuring the volume of aqueous sodium hydroxide? Of course, burette or pipette. How can we check for the reliability of the results? Double I, repeat the experiment and compare the results or take average. H, he told you a piece of information that sodium hydroxide reacts with calcium chloride to form a precipitate of calcium hydroxide, and he wants you to use this in order to figure out which is more concentrated, sodium hydroxide solution O or P. You will add a certain volume of calcium chloride to an equal volume of solution P once and solution O the other time. You will measure the mass or the height of the precipitate form and compare. The more concentrated sodium hydroxide solution forms more precipitate or gives a larger height of precipitate. Cations and anions. 2 solids Q and R, which are both salts, were analyzed. Q was zinc bromide. And then zinc is added to sodium hydroxide. Zinc cation is tested by sodium hydroxide, white precipitate, of course. Okay, and then excess, it's soluble in excess or dissolves in excess. With ammonia, the same results exactly. Finally, he used silver nitrate. We have bromide. Bromide with silver nitrate gives us creamy PPT. His testing about solution R, it gave yellow with the flame test, which means we have sodium, and it gave yellow with the silver nitrate test, which means we have iodide, so it's sodium iodide. Finally, the investigation. He says when we add solid barium hydroxide to solid ammonium chloride, a reaction takes place. He wants us to prove that the reaction is endothermic by an experiment. First of all, you will get solid ammonium chloride or barium hydroxide, and you will measure its initial temperature. You will add the other solid and stir. Stir is obligatory for this mark to be taken. Mentioning the thermometer is for a mark. Then measuring the final temperature after the reaction takes place, and we can say that the temperature will decrease because he says that the reaction is endothermic. B, how could you show whether or not the final mixture contains ammonium ions? The test for ammonium is adding aqueous sodium hydroxide and heating. Okay, warming, the gas produced, which is ammonia, turns damp red litmus paper blue, or just litmus paper turns blue. This was March 2017 by Mr. Marco Medhat.